Hello and welcome to Technical Utkranti, and in today's video we'll summarize the last two videos because the last two videos, which is part 23 and part 24 of the array series, the approach is quite similar, and that's what I want to drive through and so that you can remember it when you see a question. 23rd question involved finding subarrays that sum up to 0. Okay, okay, the approach involved finding the running sum. So when I find running sum, I start with 0 and I get 15, 13, 15 again, and so on. The approach was that if the current value of the running sum has already been found before, which in this case 15 has been found before, then the sum of all the elements subsequent to the previous occurrence of 15 till the current occurrence of 15 has actually contributed to 0. Makes sense, right? In this way, we can find all the subarrays which sum up to 0. So this guy sum up to 0. Now further evolving this question, I have to find subarray that sum up to a certain value of k. So instead of finding 0 sum arrays, I want to find k sum arrays. In that case, I need to have this particular subarray sum up to k. Then the previous occurrence should be 15 minus k, right? That's how 15 minus k plus k would give me 15. Meaning to say, whenever I have this running sum, I'll search running sum minus k into the previous occurrences of running sum, and if I find that, then it would mean that 15 minus k plus the sum of subarrays is equals to 15, and hence the sum of the subarray turns out to be 15. That's how we were calculating the subarrays which sum up to 0 or a certain non-zero value. Now in the 24th question, the question was similar. We had to find subarray that XOR up to a certain value. Let's begin with the same way we begin with understanding the summation problem, which is find all subarrays that XOR up to 0. Here also we calculate the running XOR. Just like in the previous case, we were calculating running sum. So 0 XOR 4 becomes 4, 4 XOR 2 becomes 6, 6 XOR 2 becomes 4, and so on. Here also we see that if the current value of running XOR has been found before, so for example 4 has been found before, we know that any number XORed with any other number, let's say c, and if we get the same number, it means that c is actually 0. So the current value of running XOR has been found before, then the XOR of all the subsequent array elements has actually XORed up to 0. Makes sense. Now instead of finding subarrays that XOR up to 0, we have to find subarrays that XOR up to a certain non-zero value, let's say k. Alright, so what we'll search is, instead of searching current value of running XOR into the previous occurrences of running XOR, we'll search current value of running XOR, XOR k. Alright, so when we find r XOR k previously, and the current value of the running XOR is just r XOR, then it would mean that the subarray elements XOR is k, right? So that's how the two questions are similar in their approaches. In both the questions, we are calculating running sum in one case and running XOR in another case. When I have to find subarray with 0 sum or 0 XOR, I just search the current value of running sum or running XOR in the previous occurrences of running sum or running XOR. In case I have to find subarrays that sum up to k or subarray that XOR up to k, then I will search current value of running sum minus k into the previous occurrences of the running sum, and over here I'll search the current value of running XOR XORed with k into the previous values of the running XOR. And if I happen to find them, then all the elements subsequent to the previous occurrence would give me the required subarray. I hope you got the concept of both the questions. I hope you understood the similarity in the approaches. And if you did, I achieved my purpose. Thank you. I hope you liked the video. And if you did like the video, give it a thumbs up and subscribe to my channel. Thank you. Bye bye.